Many people fear that artificial intelligence is rapidly achieving fluid intelligence. Fluid intelligence is the human capacity to reason, think dynamically, and solve entirely new problems without prior training. We envision algorithms that think for themselves and displace human workers. Yet the engineers building these systems are often quite bearish on that specific timeline. Many researchers doubt that current transformer models, the specific math architecture behind ChatGPT, will ever achieve independent, human-like thought. These systems function as brute force distillation engines. They take massive amounts of existing human data, identify the statistical patterns, and repackage them into a usable format. These models lack true, independent reasoning. They serve as highly capable assistants and digital agents, augmenting human effort rather than replacing the human element entirely. The software remains manageable, but the physical method required to refine these models is triggering a global resource crisis. To force these inherently inefficient models to generate slightly better answers, developers must feed them a staggering, continuously multiplying amount of physical computing power. While society focuses on a phantom threat of rogue code, we have inadvertently triggered a physical industrial arms race that demands more energy and capital than the built-up global telecommunications grid. Current AI progress is governed by a strict mathematical rule known as logarithmic capability. Achieving this hypothetical 5% performance increase in an AI model isn't just writing better code. That 5% gain actually requires 10 times the physical computing power and 10 times the volume of raw training data. This math dictates that the future of AI will be won by scaling physical resources at a rate that requires doubling power and hardware every few months. This scaling bottleneck pulls the AI battlefield out of the digital realm. The focus is shifting away from the corporate campuses of Western software invention and into the physical world. Feeding these models requires massive physical infrastructure. It begins with the sheer capacity of the electrical grid, drawing the enormous amounts of raw power needed to keep servers running. That energy powers the specialized hardware that processes the data. This creates a massive demand for sovereign semiconductor manufacturing, a nation's ability to design and produce advanced computer chips entirely within its own borders. The West maintains an advantage in software architecture, but China possesses a structural advantage designed for this moment. Their centralized, state-directed system is built to take an existing invention and rapidly scale its production. Because the AI race is now a war of industrial scaling, the geopolitical advantage shifts toward the East's specialized industrial base. The entire global supply chain and this physical arms race collide at a single geographic choke point. That nexus is Taiwan. This island is where the majority of the world's advanced computing hardware is physically manufactured. Taiwan's near monopoly on high-end semiconductor fabrication makes it the most critical and dangerous flashpoint on Earth for the technology industry. If China were to take Taiwan by force, they would instantly control the global compute monopoly, leaving the West without the hardware required to run its models. China is also working to scale its own sovereign semiconductor manufacturing, aiming to simply outbuild Western capacity over the next decade. We remain in this hardware bottleneck because of our current technology. Until a new, highly efficient AI architecture replaces transformers, brute force scaling is the only path forward. Until that software breakthrough happens, global supremacy in artificial intelligence belongs to the nation with the biggest factories.